to have a very brief discussion about histograms because this does actually relate to the real world, okay? And as I said yesterday, there are people in charge at companies. They are in charge of quality control. They are concerned about histograms. So I wanted to show you a couple of actual real-life examples, okay? So it says here, most manufacturing processes require that materials be purchased from suppliers. Since the quality of a finished product is to some extent determined by the quality of materials purchased from the suppliers, most companies are requiring suppliers to document their quality. So if you're Ford or GM or Apple or any company that gets parts from other companies, you are concerned with the quality of the stuff that you're buying from those other companies. Much information about a supplier's production can be determined by knowing how to read and interpret histograms. So the first one is what we call a cliff-like histogram, and it looks like this. Now, without reading ahead, any idea what this means? We're talking about length of rods here, so some sort of rod used in probably a car.
Well, you know, you go all the way up, and then all of a sudden it's a cliff edge there, so it just drops.
So what does that mean that the lower end rods aren't appearing? What does that really mean?
There's no length there.
Figure 982 presents a histogram revealing the distributional lengths of rods purchased from some supplier. Comparing the actual histogram of length of rods with the normal distribution drawn as a dotted line in figure 982, note that the missing left tail of the actual histogram. Such histogram is a cliff-like in appearance and usually indicates that the supplier screened the lot and simply removed rods whose lengths did not meet specifications. In other words, they took out all the ones that were too short. Is that a problem for you as a purchaser?
No.
If you didn't get the ones that were too short? It is a problem. How come? This indicates...
Why would you want those too short?
You don't necessarily, but this indicates that the supplier's production process is not in control and that the purchaser is paying for these screened out rods.
Well, that's terrible.
You're paying for them. How are you paying for them if you're not getting them? They're throwing them away, and so what do they have to do to the price of the rods that they actually do deliver to you? Up the price. So you're actually paying for things that you don't even get. You don't want that kind of histogram if you're buying stuff from a supplier, okay? Because you're paying for things that you shouldn't be paying for. The second one, the second kind is this kind here. It's called a fear histogram. What does this look like has happened? Suddenly there's one at the bottom there that is too tall. Figure 983 presents a histogram showing the distribution of diameters of steel rods produced by a company. Studying the actual histogram, note that the 2 centimeter is a lower specification limit, which means that the diameters below this value do not meet specifications set by the purchaser. Comparing the actual histogram with the normal distribution, note that the missing bar to the left of 2 centimeters, and also observe that the 2 centimeter bar is higher than it should be. The fact that this is occurring at the lower specification limit of 2 centimeters, in other words, they're not buying anything that's less than 2, indicates that the inspector may be recording rods with diameters of 1.999 centimeters, in other words, ones that are just below the limit, as 2 centimeters in order to give the appearance of more rods inside the specification, which is working, but what's the problem? They're not actually the correct length. You don't want to see that in your mix as well, in your histogram, okay? This is called a fear histogram because the company is afraid that you're going to stop buying from them, and they should be, because you should stop. 2 peaks like this. This presents a histogram showing the distribution diameters of ball bearings purchased from a supplier. Notice that the histogram has 2 peaks. Such a histogram often indicates that data from 2 different populations or origins are mixed together. In other words, the ball bearings probably came from 2 different suppliers. Okay, so any of those histograms are bad. Am I going to test you on them? No. I only wanted to spend these 2 minutes sort of discussing them just to give you an idea that people in the real world actually care about histograms. It's not just some math made up mumbo jumbo meant to torment you. Correct, right. You won't get any disagreement from me on that. Okay. Having said that, let's move on. Okay, so this is the textbook's version of what standard deviation is, okay? As you're going through it, you should have a general idea of what standard deviation refers to, and you should hopefully recognize that I did a much better job than the textbook did. Page 105, it's up on the screen. Okay, so mean and standard deviation. In manufacturing, the actual measurements of the finished product are often slightly different from the specification. Small deviations may be acceptable. People who work in quality control gather data on randomly selected samples of output They test the data for acceptability. If necessary, adjustments are made in the manufacturing process. Quantity used to describe a set of data is called a statistic. In this tutorial, we will use two statistics, the mean and the standard deviation, to analyze data. The mean is a measure of central tendency. Luke, you grab one of those three things and you turn to page 105. So the mean is a measure of central tendency. The mean of a set of values is the sum of the values divided by the number of values in the set. You guys should know that already. To find the average, you add them up, divide by how many there are. Standard deviation is a measure of the extent to which the data are spread from the mean. So that's basically it for explaining what standard deviation is. Okay, all that stuff I did yesterday, they summed up in one little sentence. In investigation 1, you will examine two sets of data that have the same mean but different standard deviation. So what I would like you to do, and I know you're going to hate doing this, but I don't care, is I would like you to put data set 1, 24, 26, 28, that stuff right there on page 105. I'd like you to put that into L1. I'd like you to put the 1, 2, 3, 5, 7 into L2. And I'd like you to put these ones into L3 and L4. And obviously, I'm going to have to give you some time to do that. Okay, the numbers are there on page 105. And obviously, okay, so how do you do that? You go Stat, Edit, go up, clear these out of here, press Enter, clear, clear. Okay, and what do? You just enter those numbers, 24, 26, 28, 30. Just keep going. Okay, so I have my data in there. Okay, we're going to flip the page, and we're going to construct a histogram for both. Okay, what I'd like you guys to do is I'd like you to find the standard deviation and the mean for each one of those sets. Remember, these are frequency tables, so how do we do this? We're going to go Stat, Calculate, one variable stats, right? Not two, one variable stats. L1, comma, L2. That's how it knows it's a frequency table. Okay, and I'm just going to copy and paste that over. There's L1. Now I'm going to go Stat, Calculate, one variable stats on L3 and L4.
How do I get to the one bar again?
Stat, Calculate.
Thank you.
Okay, so what you should have noticed now is that the average for both of them is 33.65, right? But the standard deviation for the first one is 4.53, but the standard deviation for the second one is 2.78, 2.79. Which one has the lower standard deviation? B, lower, higher standard deviation. How come, looking at the numbers, can you tell, why do you think these ones here have a lower standard deviation? Well, first of all, they don't start at 24, right? They start at 28, they end at 40, right? Because this is the data we're talking about. There's 2 28s, there's 5 30s, there's 9 32s. The biggest number is in the middle, 34. These guys start all the way down at 24 and they go all the way to 44. If I were to graph them, they would look like these two. Okay, look at these here. You don't. Which one is higher in the middle?
34.
The second one. The second one is higher in the middle. Okay? It doesn't have any out here on the wings, on the tails. This one has a lower or higher standard deviation. Set 2, lower or higher?
Higher.
Lower.
Oh,
When it's high in the middle, what does that mean? Lower standard deviation. You should have written that down on that. Do you have this sheet? Do you have that data? Do you have those? Did I just give it to you today? Okay, so you should be now writing on here, higher in the middle, lower standard deviation. That's how I gave it to you. Okay, higher in the middle, lower standard deviation. This one is lower in the middle. It's scrunched. It's pushed out to the sides. It has values out here. This one is higher standard deviation. The data is spread out.
So it's kind of just the vice versa.
I guess.
Lower equals higher, lower STP, the higher.
Oh,
If
but
there's
it
more
is.
bars on the side, you have a higher chance for STD.
However you remember it, man. Looking at data set 3 and 4. Which one has the higher standard deviation? Definitely data set 3. So Dylan is saying this one is higher. And then that would make this one lower, I guess, right? Do you agree, Rowan?
I'm gonna go ahead and say yes.
You're going to say yes. Can you back up your explanation?
One's on the left, so a little more spread out.
Nah, you're right, but what do you see that tells you that it's spread out?
There's less. The one on the right, they're all. Oh wait, no, I had that problem yesterday. I'm just gonna go against the grain and say Dylan.
You're going to say Dylan's wrong.
I'm gonna say Dylan's right.
Stephen, would you like to say why Stephen's right? Or why Dylan's right, sorry.
Wait, which one did Dylan think was right?
Dylan he says higher standard deviation here, lower standard deviation on the right.
You know what
Oh yeah, he's right.
He's right? Can you explain why, Stephen?
Because Dylan's a wizard.
Remember what I said? Remember I said all the STDs?
It's a wider bottom.
Yeah, it's a wider bottom.
Let's make a little G's.
So are you agreeing with him?
Yes, are you looking at me?
Yeah.
Yes, I agree with
You're agreeing with him.
Because there's 35 twos and 40. I agree. 35.
Okay. So are you saying that there's lots of numbers in the middle and hardly any out here, and so it is a lower standard deviation? Yes, that is correct.
The whole time you were asking us, you were just.
Okay, you know what, Ricky? You know what? I'm hoping that gives you a pretty good idea of what standard deviation is. A bit of a review from yesterday. Would you agree that if all I taught you was the last 10 minutes or so, 12 minutes, that wouldn't have given you a good idea of what standard deviation is? Would you agree that what I did yesterday was way better?
Yeah.
Okay, good.
So was I right though?
That is correct, the way it is, right? Okay. Higher, yes, Dylan was right, and you were right to agree with him. Okay? This is high. Look at it this way, too. How many ones are there out here on the tails? There's more out here. There's 6s. Do you see, Rowan, that there's 6 6s?
Yeah, I can't read that.
Okay, but you can see that there's more of them, right? And there's actually 4 zeros. There's only 1 down here and only 1 there. There's more numbers on the wings, so that means that it's a higher standard deviation. The more you've got out on the sides, the higher the standard deviation. The more inconsistent it is. Okay.
That'll be a question.
Yeah.
Oh yeah, for sure.
But is it like a A or B? Like
I'll probably give you 2 histograms and say which one is higher or which one is lower.
Nice.
They are easy marks. I'm not sure why I've got those 2 all over again. Okay. So what's new today? This is investigation 2. Okay. The mean and standard deviation of a binomial distribution. Now we spent a little bit of time talking about binomial distributions. Okay. A multiple choice test has 30 questions. There are 4 choices for each question. Only 1 is correct. A student answers each question by randomly guessing. Okay. We are on the bottom of page 106. So what we're going to find out is how do means and standard deviations, how do they relate to binomial distributions? So we're going to take our graphing calculator. And we're going to remember how to do that binom PDF stuff?
Yep.
Kind of, sort of?
bars.
Okay. Remember the first thing you had to do was go into edit mode, clear out your L1 and 2. You can ignore it, but it's quite often I find it's better to clear them because if you don't do it right, then you get things mixed up and it's just bad. So I'm just going to go and take care of, clean up some business here. Clean up the L3s and L4s too while I'm in there. Okay, so I got my L3s and my L4s cleared out. I'm going to do that binom PDF command. It was under second function distribution. So go second function distribution on your calculator. Second function bars, that's right, Steve. Remember, you got to find binom PDF. PDF. Mine is under A. I think you guys have it under 0, right? Many of you? So pick the one that says binom probability distribution function.
There's two of them.
The one has a C, one has a P. PDF.
It says that there.
You should have it just on your home screen like this, Steve.
Yeah.
Okay, so if you haven't gone there, clear, get to your home screen, then second function, vars, binom PDF. Now, how does this work? There's 30 questions, so we're going to do 30 trials, so 30. It's a multiple choice. There's 4 questions, so it's 25% chance.
Where'd you get that comma?
0.25. I pressed the comma button right above the 7.
I didn't see it. I've never done this.
You might have been away this day, Steve.
Yeah, those are the.
Yeah, could have been. Binom PDF 30, 0.25. We're going to take that data. What are we going to do with it? Where do we want to store it? Store it where? Do you remember, Janelle? Yeah, store button right here, just above the on button. But where do we want to store it?
L2.
It's not. It's L2. You're right. It's L2. I'll explain right away why it's L2. We're going to put it in L2. So it takes all that probability. Instead of doing a great big giant tree diagram, it does that all for you, puts it into L2. What do you have to do? You have to go into L1. Do you remember what you have to do now? Once you've got those in there, we got to put in L1 the numbers. How many questions were there?
30.
There was 30, so we got to put the numbers. Is it 1 to 30?
0.
Why do you start at 0? Because you can get 0 right if you're that unlucky. So you can go 0. Oh, geez.
Is there a quicker way to put in 0 to 30 or something?
There is, but I got to spend about 20 minutes teaching you how to do it.
Let's do it.
If you happen to have the program filled down on your calculator, then you can go pick it and it will fill the numbers down for you if you want.
How do you do that?
If you have the program filled down,
Where's the
Wait, I don't-
go program, fill down. It's a little program that some smart guy wrote to fill a list.
I only have that one.
Then you're out of luck.
So do we have to use our program thing on test?
If you, yeah,
Store it.
no, not to store notes. You've got a cheat sheet. I do realize it's a bit of a pain having to go like this. Oh, especially when you miss one.
Why are your E's
Estimated.
E means times 10 to the power of.
No, I know.
Okay, so I'll give you a second to punch those in. I've got now my probability distribution here for this quiz, for this test, 30 question test. I want to know what the average score is going to be. What do you think the average is going to be on 30 questions if you have a 25% chance of getting an answer right? What would be the average mark out of 30, do you think? Give me a number. 15? You think you would average half of them right?
7. 11.
Why 7?
22. I just took a shot in the dark.
Okay.
Half of 15.
Okay, that's pretty good. We're going to go calculate one variable stats. Remember to go L1, comma L2. And Steve's right. The average is 7.5.
You said so.
He said 7, but he knew that you couldn't get half a question right.
Alright, well,
Okay. So when you punch all those in, and I'm just going to write down the question here for reference. 30 questions, 4 answers. So we went binom PDF 30, comma 0.25. We stored that into L2. That's what we did, right?
What did you do to get that screen?
I went stat, calculate. I want to take the one variable stats on L1, comma L2. Okay, it gives me the average of 7.5, and you'll notice that the standard deviation is 2.37. Well, whoop-de-doo. 2.37. Now, how many people would like to do that every time, or who would like to see a shortcut?
Now, like shortcut.
I'm thinking the shortcut. Okay? Now, I could go the long way and get you to figure it out, or I could just give it to you. There is a shortcut. It's on page 107, and it's in purple. It's in purple. It says here that the mean is equal to n times p. The mean is equal to n times p, and it says that the standard deviation, which I will put as a symbol, is equal to the square root of n p, and then they go 1 minus p. Okay? And I'm going to explain what those things mean. This is the big idea for today. Okay? What does n equal? N refers to the number of trials. So in our 30 question example, you had 30 chances to guess the correct answer. So in this particular example, our n is 30. Our p is our probability of success. That's correct. Probability of success. Because there's 4 answers, your chance of getting it right is 0.25, 25%. Right? Make sense, Bob?
Yep.
Now the other one, I don't like this 1 minus p stuff. It's kind of clunky. I'm going to call 1 minus p, I'm going to call it q. Do you have it written in your book as q at all? Anybody got that written in the textbook? You go right ahead and write in that textbook. It's the last time that textbook's ever going to be used.
Where?
Right in that purple box. I want you to write q equals 1 minus p. And q is equal to the probability of failure.
I take this textbook out.
Like as a souvenir? Just because my name's on the back of it, Ron?
Well, why is it because of numbers are?
Q is equal to 1 minus p is the probability of failure. Well, 1 minus p is going to be 1 minus 0.25, which is equal to 0.75. You have a 75% chance of guessing each one wrong. Makes sense, right? There's 3 out of 4 wrong ones. So rather than write the sigma here is equal to square root n times p times 1 minus p, I'm going to write it like this. This is the way I prefer it. NPQ. It's just a little cleaner.
This doesn't sound like a shortcut.
Oh, it is. I'm just defining it for it. I'm going to show you how short it is. Right away, Rowan. I'll tie it all together at the end. So the mean is n times p. The standard deviation is square root of npq. Now, Rowan's got a great question. He says, this doesn't sound like it's short. Do you have to do that every time? No, I'm just showing you the shortcut. Here's how it actually applies to this question. Okay. We've got 30 questions. We've got 4 answers. So my mean, which is my letter mu, is equal to n times p. My value of n is 30. My value of p, 0.25. As Stephen did several minutes ago, he took 30, divided by 2, and then divided by 2 again, knew that it was 7.5, but rounded down because he knew you can't get half a question right, right?
Yeah.
You're almost right.
Well, you can.
30 times 0.25 is?
Well, if it's multiple choice, you can.
Well, no, you can't, but let me explain what that means. 30 times 0.25 is 7.5. So the average person, if all they did was guess, the average person would get 7.5 right. You can't get 7.5 right. What it really means is if you all did it, because some of you are going to guess better than others, right? But if you all did it, what would be your average mark as a group? 7.5. So some of you would get 8, some would get 7, some would get 9, some would get 6, but the average would be 7.5.
I should test this.
Yeah,
Here,
we
get
should test
a bunch of random questions that we would know.
We could.
Because I don't believe it.
Well, we could. The average mark would be 7.5.
Let's do it.
What would be the standard deviation? The standard deviation is equal to square root n times p times q, which is the square root of 30 times p, 0.25. Q is 0.75. So with your graphing calculator or any normal calculator,
2.37.
Wait, a while ago, didn't you say it would take for us to work on it?
Did I say that?
Yeah, you said it would take forever. Yeah.
No, oh no, I was something different. That was the fill down thing.
No.
No, it was the fill down thing I was talking about. So you're going to take 30 times 0.25 times 0.75, and then you're going to take the square root of that, second function answer, and look at that, 2.37. Now, you tell me, which is shorter, Rowan? Going 30 times 0.25 and then 30 times 0.25 times 0.75 and taking the square root to get the mean of standard deviation. Is that shorter than going binom PDF 30 comma 0.25, store it into L2, go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all that, and then one variable stats? Which one is shorter?
I'll probably do that.
The second way is shorter. Right? You think so?
Too many numbers.
It's just a formula.
Too many formulas.
It's just a formula. Okay? Now, in this textbook's infinite wisdom, they showed no examples whatsoever of that NPQ.
That's why you're burning.
No, I'm not going to burn it because it is a bit of a souvenir, but I certainly complain about it every year because they don't even give you an example.
Well, you might as well break the entire book then.
I should have. If you want to do it right, do it yourself, right? I agree.
Well, this is your last time, too.
Yeah, I agree. Okay, well, there are some questions you can do here. I would urge you to do, and I'll give you a few minutes here to work or to do whatever you need to get done. On page 108, I would strongly suggest you do number 1. That's another one of those, which one has a standard deviation. Actually, 1, 2, and 3 are all that. If you want more help on which one has a higher standard deviation, do 1, 2, and 3 in about 30 seconds. Okay? You should probably do 1 of 4 or 5. And you should probably do number 9. Okay, hang on. Okay, so I would suggest 1, 2, and 3, 4 or 5, number 9. If you think you need more NPQ questions, and the answer to that question is yes, I do. It's only 1. Okay, I made up a bunch more of I call them NPQ questions. Okay, they're on that sheet there. There's some answers there. So I would do 1, 2, 3, 4 or 5. Do number 9, and probably a couple of these guys here. I know that's a lot. Now you can go. Was it? Yeah.
It's your turn to do the plays.